start configuring this BSR bootstrap router, right? I don't think so that you people will be able to understand anything from it, because we have already gone through all these topics, right? Like what is multicasting, what is rendezvous point, what is the role of it. So have patience. uh, might be from tomorrow I will start DMVPN, right? So today I will cover all the topics which are in multicasting. Might be that, of course, it's not possible for us to cover all topics of multicasting by today itself. Even I'll continue your multicasting tomorrow as well. But along with multicasting, I will also start your DMVPN, right? And then after I will. So now I'm going to configure this BSR. I will start it from R2. I'll move on R2 and I'll configure this R2 as candidate BSR. Let me specify over here. I'll configure it as a candidate BSR. Along with that, I'll configure this R3 as a candidate BSR, right? So let me do one thing. I will start from R2. So I'll say what? IP pim BSR candidate loopback 1. Fine. So it have become candidate for BSR. Then we can move on to R3 as well. In same manner, I'll configure this R3, and onto R3 I'll configure it as again candidate BSR. For doing that, IP pim BSR candidate loopback 1. Both of them have become candidate BSR. Any one of them will be elected as a BSR. You can move on to R4. You can see that which router have been elected as a BSR. For doing, to check that, show IP pim BSR router. So it will show you that okay, R3 have won this election because R3 was having higher BSR address. You want to configure, if you want to configure that R2 should elect this BSR election, then you can do one thing. IP pim BSR candidate hash mask length is by default 0. You will take it 0 as well. Then priority is what? 1, higher than 0. So it will become, it will be having higher priority than R3. So that now if you move on to R1 or on to R4, you will see show IP pim BSR router. You will see that now R2 have been elected as a BSR router. You can also move on to R4 as well. Now previously it was 3, but now it will be 2 because its priority have been configured as 1, which is higher than R3, because on R3 by default BSR priority was 0. Fine. So now we have configured this R2 as a BSR over here, and then after it I'm going to configure this R1 as a candidate RP, as well as I will configure this R3 as a candidate RP as well. So for doing that, I will move on to R1, and on to R1 I'll say, you remember here I will say IP pim RP candidate loopback 1 onto R1. In same manner, see, pim version 2 is not running onto loopback 1, so you cannot configure it as a candidate RP, right? So for doing that, go to loopback 1 and then say IP pim what? Sparse mode. Now you can see that you can configure it as a RP candidate. Then after you can move on to R3 as well. On to R3 also you can say IP pim R3 is configured as candidate BSR as well as candidate RP. So IP pim RP candidate loopback 1. So it means that here pim was already enabled. Yes, pim was already enabled on this loopback. That's why it didn't give us that error message. Now on to R4, you can move on to R4 and you can see show IP pim RP mapping. Both of them are coming, but finally this end router will elect any one out of these RP addresses, out from all these these 2 RP addresses, right? So right now 1 and 3, both of them are working as a RP, but any one out of them will be elected as RP, right? If you want to see that who is your RP for which group, then there is a command. On to all routers, if you configure this command onto R1 as well, so IP pim RP mapping. See, these 2, 1 and 3, onto R2 as well, so IP pim RP mapping. Fine. On to R3, show IP pim RP mapping. Fine. You understand? So 1 and 3, all these two routers are working as a candidate RP. So as opposed to mapping agent, BSR do not elect RP by itself. BSR will create RP list and will distribute it among all devices. So all devices are having this information that there are now two RP addresses, two RPs available in this multicast domain, right? So now you do one thing, move on to R4, and on to R4, if you want to see your RP address for a specific multicast group address, let's say show IP pim RP hash, and then group address 230.1.10. So this 333 is the RP. Even on to all routers you can configure this command. Move on to R1. So what's that? 3333. On to R2 as well, 3333. On to R3 as well, 3333. You understand? Right? Then after it, on to R1. See, there is hash value for both RP addresses. This hash value will be common on to all, as you can see, and see, there is a common RP for that group, right? There is a common RP for that group. And I would like to tell you that by default in BSR also, if you are having multiple RPs and if they are having same priority, then the higher RP address will be preferred. Higher RP address will be preferred, will be elected. And here you can see that for all groups, like you can move on to R4, any router, and you can check RP address for any group. So IP pim RP hash. Yes sir, which one? 333. This is the elected RP by this router for any group. 225, 226, 227, 235, 239. For all, it's same. It means by default BSR also will not perform any load balancing. Yes, there is redundancy, but there is no load balancing. Now, in case if you want that R1 should be elected as RP on to all devices, then remember that in RP election in BSR, see, I'm not talking about the BSR election, I'm talking about now RP election. Lower priority will be preferred. In RP election, lower priority will be preferred. Higher RP address will be preferred, but in terms of priority, lower priority will be preferred. So in case if see, both of them, like R1 and R3, both of them are having same priority, 0 for candidate RP, right? And now what will I do? I will move on to R3 and I'll configure its priority as higher than R1, and the command will be IP pim RP candidate loopback 1, and then after you can configure your. By default it sends messages in every 60 seconds, so if you want to change that, then you have interval keyword over here. If you want to configure it as a RP candidate for a specific group or for a group of group addresses, then you can use group list. In group list you can call your standard ECL. So priority is what? 1. So higher will not be preferred, lower will be preferred. R1 will be having its default as 0. So now you can move on to R4 and you can check for any group now. 225, it's what? 111. For 226, it's what? 1111. 227, it's 1111. 235, 1111. Because it is having lower priority. So this time you can see when priority is different, then it is not comparing its hash value, because hash value means that higher will be preferred. But this time, because election has already completed based on priority.
So hash value is calculated on basis of RP address?
Of course, on the basis on RP address, hash mask length, group address, everything. There is a formula actually to calculate this hash mask value. It will see whenever your BSR will calculate hash value, it will consider your RP address, it will consider your group address, it will consider your RP address, as well as it will also consider hash mask length value, hash mask length, and which will be mentioned in BSR actually. Show IP pin BSR router. Hash mask length is what? 0. So it will also be considered during hash value calculation. So three things are there, three major components are there. One, RP address. Second, group address. Third, hash mask length. And higher hash value will be preferred, but hash value will be compared in case if your priority is same. If it is different, then definitely your RP election will be performed based on its priority only. Now again there will not be any load balancing, because now R1 have become RP for all routers, for all groups. Move back again on R1. Sorry, not on R1. We configured priority onto R3. Make it 0, which is by default. And once again onto R4. Oh, sorry. IPPM RP hash. See, once again it is for all groups. But again there is a problem. The problem is again there is no load balancing, because for all groups there is a common RP, which is R3. You can check hash value for any group, right? And because all of them are having same formula, that is why there will be a common RP for a single group, right? There will not be any mismatch, like for R1 its RP is 11111, for group 230.1.1.10, and for R4 its RP is 3333 for the same group. No, it will never happen. For a single group there will be a common RP for all devices automatically. Don't worry about that, right? Apart from it, if you want that no, it should perform load balancing, then show IP pim BSR. Right? So by default hash mask length is 0, and we can achieve load balancing in BSR by modifying hash mask length value. This hash mask length is same as prefix length. Do you remember subnet mask? In subnet mask, what was the meaning by /30? Tell me, what was the meaning by /30 over there? Means 2 bits for 4 hosts, and there was a block of 4 addresses, right? 4 addresses. Right now its hash mask length value is 0, means all 32 bits are for host, which means that for all group addresses there will be a common RP. For all group addresses there will be a common RP. But if you take your hash mask length value as 30, it will be up to 32, right? It will be also up to 32. Let's say you have taken 31. Let's say you have taken 31. So how many bits are left? Only one. One bit means group. There will be two addresses, right? So what will happen now that for first two groups there will be one RP. Let's say that you are having multiple RPs available in your multicast domain. So for first two addresses there will be one RP. For another two addresses, for another two multicast addresses there would be another, different RP. Then for next two addresses there will be another RP, something like that. You understand? Now I'm going to achieve that. So where will you change your hash mask length value? On BSR. And who is your BSR? R2. So move on to R2. Do you remember this 0? Before priority we specifies hash mask length value, and it is in between 0 to 32, right? And now you can configure it in between any value in between 0 to 32, right? So I will make it 31, and then after we are having here priority is what? 1. So this time hash mask length value is what? 31. One more thing, in case if this R2 goes down, then who will become BSR? R3, because R3 is working as both candidate BSR as well as candidate RP, right? So now R3 will become BSR, and onto R3 still its hash mask length value is what? 0. So it will be better to change your hash mask length value onto redundant BSR as well. So move on to R3, and you configured this command to configure BSR over here, this one. So loop back 1, and then after you can configure hash mask length value is what? 31. Got it or not? Fine. So in case if R2 goes down, then R3 will become BSR, but hash mask length value will remain same. Now move on to R4. See, I'm on R4. Show IP pimBSR. So what is the hash mask length value now? And not only on this router, if you move on to R1, if you say show IP pimBSR, what is that now? On to R2, show IP pimBSR, what's that? 31. On to R3 as well, show IP pimBSR. It is what? Tell me. 31. And see, this is also candidate BSR 33, and its hash mask length value is also 31. But who is winner? We are winner, and ours hash mask length value is also 31. This one 2222, right? Fine. So all of them are having this information that hash mask length value is what? 31. You do one thing, move back again onto R4, and this time check it out. Show IP pim BSR. Sorry, show IP pim RP hash for 230.1.0. Starting from 230.1.0. What's that? 1111. It's 111. However, previously it was always defining what? 3333. For 1 is what? Again 111. For 2 it's what? 333. For 3 it's 3333. For 4, for 5, for 6, again 111. Now for 7 also it will be 1111, right? But for 8, my god, this time it is not changing it. 111 for 10, for 11, but again it is in multiples of 2 addresses. 12, 13, 14, 15, you understand? And for 16, 1, 17, 1, 18, 1, 19, 1, but for 20, 21, wow, this time it is now 22, because it will start from 22, right? Then 23, 24, 25, 26, 27, 28, 29. In somehow you can see that it is performing load balancing in that manner that I explained it to you. However, it will be depending on your hash value calculation. It will not be exactly like that, okay, for first 2 it will be first RP, then no. Now it will try to get load balancing in that manner, but it will not happen exactly. But see, in somehow we have achieved load balancing, right? And in case if one of the candidate RP goes down, then for all groups there will be a common RP, no problem. So redundancy as well as load balancing is there in BSR. So I hope that you people have understood the uses of BSR and also advantages of BSR over auto RP. Is not it? So that's all about it. See, this is the mask value. That's what we took. Vishnath, are you okay with it? Great. Fine. Now the point is, okay, we have came to know that how BSR works and everything, right? Everything, no problem at all. Now the point is, like in auto RP we were having TTL scope, right? For security purpose, so that our auto RP messages will not cross our boundaries. You understand? It's not a Piyush. Over there we were having scope TTL values, but in BSR there is no TTL value. There is no scope value. It means there is no security, but it doesn't mean like that. There is a security. There is a command. Like for an example, this R2, R3 is a, like for an example. See, just try to understand in this manner. R2, R3, R4. Are you getting my point? And then this is what? R5, and this is what? R6. This is one AS, and this is one another AS. Now AS1's RP's information, let's say this is R1 and which is configured as RP, should not move into AS2, and AS2's RP, because of course my RP's information should not go out from my own domain. So how will you achieve in case of BSR? Because of course there will be PIM neighborship, because you have to take traffic, multicast traffic from here to there and from there to here. So you have to configure PIM neighborship in between R3 and R4. And if there is PIM neighborship, then definitely BSR will forward its information in another multicast domain. Is not it, Piyush? So in this case, what can we do on 2R3's this interface? We can move on to this interface. Let's say this is 0 by 1. I will move on to this interface. Like I'm on R3 and I'll move on FA 0 by 1, and then I'll say IP PIM BSR border. That's it. This BSR border, I will configure this BSR border command over here onto this interface. This BSR border is same as BPD filter in port security. I mean in switching. It is same as BPDU filter. Like in BPD filter, it does not send BPDU messages out from that interface, and also if it receive any BPDU, then it will ignore them. In same manner, now after configuring this interface as a BSR border, BSR will never send any BSR message out from this interface, and in case if it receives it from R4, then it will not process those BSR messages. It will not process those BSR messages. Fine. This is the uses of BSR border. So there is no detailed security, but in this way you can configure that, right? And also there is multicast boundary as well. Apart from BSR, I'm not talking about a BSR or auto RP. I'm just talking about the multicast boundary. I'm having a multicast stream in my own AS for group 235.100.100.100. Are you getting my point? I don't want that this stream should go out from this interface. I don't want to let this stream to go out from this interface 0 by 1. It means this stream should be present in my own multicast domain only. So for that purpose we can configure multicast boundary as well. Like onto R3 0 by 1 you can configure this command as well, that IP multicast boundary and then your ACL. You can configure simple standard ACL. So whatever you will permit over here, it will be permitted, like 10 out. So you can deny anything and you can permit anything. So if you deny anything, then it will not allow multicast traffic for that group address out from this interface, right? It is same as like IP access group. Do you remember IP access group? But IP access group will work only for, like over there you can configure kind of like you cannot actually with using ACL also you can filter that kind of traffic, but you still see for multicast traffic we are having these commands over here. So you can define out and then enter. You can configure multicast boundary in both directions, in as well as out. In T-shoot they can filter your group address in this manner with using multicast boundary as well. So be aware with that over there. Right guys, I hope that you people can do it by yourself now. So in this way you can configure your multicast boundary. Apart from it, now we have finished auto RP, we have finished BSR, we have finished sparse mode as well. Now the problem is like whether you are using dense mode or sparse mode. Still there is a problem. Problem is like this. For an example, there is a multicast domain, use R1, R2, R3, R4. This is a kind of cloud actually. You understand? Behind R1 we are having a multicast source. This is a source. Behind this router also we are having source. Here also we are having source for same group address. Means we are having multiple sources for a same group address. All of them are generating same string. Now user is behind like R4, R5, R6, R7 and R8 over here. Like there is a user behind internet wants to join this group address. Let's say that it was 230.1.1.100. Let's say it is what? 230.1.1.100. Right? Now the point is if it is like that. From here, whenever it will join this group, it can join it from anywhere. It will be depending on RP actually, that how RP connects these two sessions, right, between RP and source and between RP and group member, right? It will be depending on RP, that which path is the best path for RP. Fine. But in case if this user wants to join it from this source A, source B is there, C is there, let's say this group member user sorry, wants to join this group from source A only, from source A only. Will it be really possible? Now, have we performed anything like that I want to join it from there only? Never. And we never performed that. So basically for that purpose, like if you wanna join a source specific group, like I want to join this group but from particular source, right? So for that purpose here in multicasting we are having SSM, source specific multicast. In sparse mode, do not use RP. In SSM, there will not be any requirement of RP. Just configure sparse mode and then enable SSM, source specific multicast. And one more thing I would like to tell you, that it will be supported in IGMP version 3 only. That's why we are having here requirement of ICMP version 3. So if you are not implementing SSM in your multicast domain, then you will never require to enable ICMP version 3 in your network. But if you are going to implement SSM in your network, then definitely you have to implement ICMP version 3, because whenever in ICMP version 3 it will generate report message, because end user will always generate report. In that report message you can also specify your source address. Till now it was not possible. You were simply saying that IGMP join group this, but you were not specifying that I want to join this group from this particular source. Never. So that was not possible in IGMP version 1 as well as IGMP version 2. But in IGMP version 3 it is also possible to specify your source. It is also possible to specify your source, that okay, I want to join this group but from this particular source. So now we are going to enable what? SSM. Are you getting my point or not? Have you understood it? For sure. Okay. So for doing it, first of all, let me remove RP's information from all of them, from all devices. Do show run pipe section IP pim. I will remove all configuration related to rendezvous point. I will remove this BSR. Fine. Now you can move on R1 and then you can say clear IP pim. Try to pin RP. Nothing. Now I'm going to enable sparse. SSM. See, sparse mode is already enabled, as you can see here. Show IP pim interfaces. S version 2. S means version 2, pim version 2, and sparse mode. And show IP pim neighbors. Neighborship is also there. already. PIM is already running on to all devices. Enable SSM now. To enable SSM, and one more thing. For SSM, there is a dedicated range of group addresses, which is 232.0.0.02, 232.255.255.255. This is the default range for SSM. You can enable SSM, default SSM onto all devices, then you will be able to use SSM only for this group range. Only for this group addresses range, not for all groups, right? So you can move on to all devices now, and then you can say IP PIM SSM default. As you can see, before default that it will be 232/8, right? Is not it? Do show history. Have you understood it? Sure. So I just enable with using single command. Fine. Now I will move on to source, and because I will be using group address from that range only, which is from default, right? Like ping 232.1.100 and then repeat that much, right? It's not getting replies from anywhere because no one have joined this group yet. Then go to multicast destination and on its F0/0 say IP ICMP version what, and then say IP ICMP join group 232.1.100, and then you can also specify your source from where. Is not it? I want to join it from there. You see, what is happening here? Yes, there is, but outgoing interface is not. Why? Okay, I didn't enabled ICMP version 3 onto R4 as well. So say IP ICMP version 3. Because it sent IP ICMP version 3 report message, but it didn't understood that, because here ICMP version 2 was running here at this end. So host, I mean your desktop as well as your gateway must support ICMP version 3. Now in case if you move on to R2, and from R2 also you can generate same string like ping 232.1.100 source is it's on loopback. Repeat. It will not get replies from anywhere because no one is receiving it. See, it is also generating the same string, but it is not getting replies, but still see it is getting replies. Now what will I do? I will move on to source and I will remove this command so that will stop to receive replies, right? Because now it is not receiving that multicast string from anywhere. See, it have also stopped to receive replies from there. It's not it, because no one is receiving this multicast string this time. Move on to our this receiver, and this time say IP ICMP join group 232.1.100, and when source is what, 2.2.2, which is the loopback of R2. And you will see this time R2 will start to receive replies from there. You see. So it's up to us now that from where we want to receive this multicast stream. See, there are two sources for the same multicast group, but it's up to end user that from where it wants to receive that multicast stream. And now you can check their mroute table as well. Like you can move on to R1, show IP mroute. You see that yes, S small s means it is what? Sparse mode. You can move on to R3 as well, show IP mroute. S comma G entry, yes, S T S means sparse mode, small s means sparse mode over here. See, sparse, I mean SSM, sorry, not sparse. Small s means SSM group, right? But the point is, from multicast source, let's try to generate multicast stream for 230.1.1.100, right? And then I will join it onto multicast destination, and this time I'll say that I'm going to join 230.1.100, right? It was 230 this time, right? But will it start to receive replies from there? No, it's not. Why?
So
No. By default, SSM do not support these group addresses. It supports only from 232.0.0.0 to 232.245. It will not work for this group. If you want that SSM should be used for all groups from 224.0.0.0 to 239.245.245 for all, do one thing: create one ACL access list 10 permit 224.0.0.0, then 15.245, and then IP pim SSM list. In place of default, use range, and then ACL number was 10. Do show history. Use this command everywhere. Onto R4 as well. Now see, for that group address 230.1.100, it have started to receive replies from there, because now it have started to support, I mean to use SSM for all groups. This is called source specific, and there is no need to have RP. You know why? Because we already have this information that who is the source. Basically, RP was responsible to tell that who is your source for this group address. But this time we are already having this information that okay, this is the source, I want to receive it from there. That's why there is no need of having RP, rendezvous point. Right guys? So in this way you can configure SSM. Now I'm going to remove this SSM, and this time I will show you that what is the uses of tunnel in multicasting. In multicasting also you can configure GRE tunnel. Let me remove SSM from all. Fine. Even now, what will I do? Let's say there is no multicast destination router. There is only R3. There is only R3. You understand? And its IP address is what? 333, which is reachable from R1. Now point is, let's say this R1 is placed into headquarters and this R3 is placed into branch office. Fine. Headquarters have taken 2 connections, branch office have also taken 2 connections. Fine, very fine. And these 2 routers, R4 and R2, they do not support multicasting. They do not support multicasting. So what will I do now? I will move on to R1. I will remove pim from S1 by 0, no IP, pim, sparse mode. On S1 by 1 also, no IP, pim, sparse mode. Do show is way. Sorry. I'll configure same command onto R2 as well. And then I'll say no IP. I have disabled multicasting routing 2 onto R2. But unicast routing is still there, right? In same manner, I will move on to R4. I'll disable it. And then also I'll say no IP multicast routing. Right? Any problem? So now I have removed multicasting from R4 and from R2. Then I will also move on to R3 and onto its S1 by 0. I'll say no IP, pim, sparse mode. Onto S1 by 1 also. Fine. And the problem is multicast stream is there onto source. We have to receive it onto R3. There is a loopback onto R3 or somewhere else, like we can create another interface. We want to receive that stream over there. Are you getting my point? So now we know that with using unicast routing from R1 we can reach R3. There will not be any problem with using their loopback addresses. So what will I do now? What will I do? I will move on to R1. Are you getting my point? And then onto R1 I'll create one tunnel interface. IP address, let's say it is 10.1 onto R1. And then tunnel source is going to be 111 and tunnel destination is going to be, because it is reachable from here, right? And then I will move on to R3, and onto R3 I will do the same configuration. I will create one tunnel interface. IP address will be, let's say 10 dot. Tell me, do you remember that we are using GRE tunnel? We are always using this GRE tunnel just to cover black hole. So this is also black hole for multicasting. And then tunnel source is going to be, and tunnel destination, it will come up now. Fine guys. And now do one thing. You are not required to configure this EIGRP onto tunnel interface, right? And here I use 000. So what will I do? Router EIGRP, I think it's 100 passive interface tunnel 1. In same manner I will be on R1 and router EIGRP 100 passive interface tunnel 1. What happened? Oh, it's process 1. Passive interface tunnel 1. onto R1 also. Router EICRP1 passive. Right, guys, we have configured tunnel, and now we can communicate with each other with using tunnel interface. Are you getting my point or not? Now you do one thing, move on R1 and onto tunnel interface itself, go to tunnel interface and then say IP ping what? Sparse mode. Are you getting my point? And then in same manner I will move on to R3, and on R3 also I will go to IP pim. Now they will form, R1 and R3 will form PIM neighborship with using tunnel interface, and now R1 can send this multicast traffic over the tunnel, right? So let's do one thing, let's configure R1 as a like IP pim, hello, IP pim RP address. Let's say I'm configuring it manually, right? IP pim RP address 111. In same manner I will move on to R3. I'll say IP pim and now from source 230.1.100, and now let's move on to R3. On to R3 I will move on to its loopback one IP pim, so the IP ICMP join group what? Onto multicast source. Is it receiving any reply? No, it's not. It means that R3 is not able to receive multicast string. R3 is not able to receive multicast. That's why ICMP replies are not there, because if ICMP echo requests have been delivered onto destination, it means from there we must receive ICMP echo reply. So this time onto R3 we have to check its mroute table. So IP mroute table, check it out. Is there any S, G entry? No. You know why? You know why? Because whenever it will send, it should send actually it won't be able to send join messages. You know why? Because RP is not reachable via tunnel interface, and it is having PIM neighborship via tunnel interface only. It is having, try to understand, it is having RPs. See, from R3 you can reachable RP via physical interface, whereas PIM neighborship is available on tunnel interface. So you do one thing, apart from using RP and sparse mode, let's use dense mode, so that it will be more clear for you, right? It will be more clear. But here also you can solve this problem by using mroute, static mroute and all. What?
The IP address of RP and the tunnel source address.
See, point is, join messages can be forwarded out from tunnel interface, but the RP address 111 is not reachable via tunnel. It is reachable via physical interface. Is not it? Because R3 is already having that route in its routing table. So will it be possible for it to send join message out from S1 by 0? Never. So you do one thing, say IP mroute. And destination will be, next hop will be tunnel address, tunnel 10.1. This is that how can we reach RP. Now see, so IP mroute. S comma G entry how came? Previously it was not there. See, we configured it manually, right? That this is your RPF neighbor to reach RP. But the problem is when packet, multicast packet received onto tunnel interface, because of course this R1 is working as RP and it received a join message onto its tunnel interface, so it will start to send multicast packet out from tunnel interface. But problem is on R3. Whenever R3 will receive multicast packet onto tunnel interface, it will check its source address, which will be again 1.2. It will perform lookup in its unicast routing table, and it will be reachable via physical interface, not via tunnel. So according to the RPF check rule, there is a RPF check rule, actually reverse path forwarding rule. I have already taught RPF rule, right, in multicasting. According to that rule, if you receive any multicast packet onto any interface, then it will check its source address first, and for that source address it will perform lookup in its unicast routing table. If the source address of that multicast packet is reachable out from that interface only where it was received, then only it will accept that multicast packet, otherwise it will drop that. So this time it is receiving multicast packet onto tunnel interface, source is coming as 1.2, but whenever R3 will perform lookup in its unicast routing table to reach 1.2, it is reachable via physical interface. You see 191.168 is not it, so it will drop all incoming packets. So you have to configure now two M routes. Now I'm going to configure another M route, IPM route, forward source 1.0, 255, 1.1 will come in it, right? And then next stop should be what? 192.168.10.1, which is tunnel address. This time I have configured this thing manually, so that it will not rely on unicast routing table. It will, because this is statically configured, it will prefer statically configured route, right? So now you see show IP M route. This time everything should be fine. See, incoming interface and outgoing interface, and over there it have started to receive replies from there. See, is not it? See, Piyush. So many things are there, so many things. You just need to know that what is happening in the background and what do you want to achieve actually. See, this is not like I was remember or I was having everything in my brain before doing these kind of things. Even I performed usually this practical over dense mode. But see that how we solved the problem by using M routes, and we configure two M routes. One is for RP and one is for source. Right? And on to R2 and R4, of course there is nothing. You capture this link because from R1 the best path to reach R3 is this link, right? So you can capture this link and then you can see that GRE header is always there onto all multicast packets. This is multicast, right? But you will see that it is a unicast packet. See, because it is going through tunnel interface. That is why transit devices will not be able to open it. And if multicasting is not enabled onto transit devices, then also they will allow it, because for them it is a simple unicast packet. That is why R2 and R4 are not creating any problem. I hope you people have understood it now. Tell me. Piyush, is that? Tell me. Guys, if you are having any problem, please let me know, and if it is not, then there is a concept of bidirectional PIM as well. Right now our tree was unidirectional, our multicast tree was unidirectional. Why are we saying that okay it was unidirectional? Because source was sending multicast stream, it means it was sending only, it was not receiving the same multicast stream. Was multicast source member of the same group for which it was generating multicast stream?
No.
Tell me. In bidirectional PIM, as per its name, see bidirectional. Sometimes what happens if you are doing video conferencing in your network, and like let's say that there are 10 or 20 users in your network, right? So all of them will be generating data as well as at same time they will be receiving that traffic for the same group, because all of them are in same group, is not it? Try to understand, just try to create picture in your brain that if you are having a multicast domain, like you are working for an organization and over there you are having some video phones, video IP phones, and all of them are the member of a group. So all of them are generating multicast stream for the same group and also they are receiving for the same group as well. So in that case you will require to configure bidirectional PIM. Bidirectional PIM. Are you getting my point? So if you are configuring bidirectional PIM, in bidirectional PIM, source can also become the member of the same group for which it is generating multicast stream. Are you getting my point? So for that purpose here we are having bidirectional PIM. So for doing that, what will I do? Let me do one thing. Let me remove it from here. No interface tunnel 1 onto R3 as well. No interface tunnel 1. Do show history. Remove those mroute as well. Look back 1. No. And do show history. No RP address. Where is that? I'll not configure static RP, right? And once again, I'm going to enable multicast routing onto these routers as well, R2, R4 everywhere, right? And I will also take this multicast destination now in picture. Fine. Move on to R1. IP PIM sparse mode. IP PIM is sparse mode, right? Fine, guys. Let me take let me copy all these commands and then I'll paste it here. Okay, IP multicast routing. You understand? Onto R4 as well, and then fine, great. Sparse mode is enabled. They are having PIM neighborship. After configuring PIM neighborship, now say bidirection IP PIM. Just configure this command onto all devices now. Do show history. This one, IP PIM bidirectional enable. Now let's configure BSR to propagate your RP's information. Otherwise, we will require to configure RP address manually, right? So what do you want? Static RP or BSR or auto RP? In all, it is possible, right? So if you are going to configure BSR, then make it, let's configure R2 as candidate BSR as well as candidate RP. So I will say IPPIM BSR candidate loopback 1. At same time, I will say IPPIM IPPIM RP candidate loopback 1 and then say bidirectional. This is mandatory to add bidirectional keyword whenever you will configure any device as a candidate RP, right? In auto RP as well. And if you are configuring static RP, then you will say IPPIM RP RP address is what 1111 and then so everywhere you will find now this option bidirectional, right? So this time if you move on to any other device, for an example onto R4, say show IPPIM RP mapping. This is you can also say in use. And what is it showing? Bidirectional mode. You understand? And this time what will I do? I will do something different this time. You understand? This multicast source is there. Even I will make it member of the same group. I'll do one thing. Interface FA0/0 IPIGMP join group 230.1.10. Fine. And then I'll create a string ping 230.1.10. Repeat. So it will start to get replies from itself. 1.2. And then after move on to multicast destination, say IPIGMP join group 230.1.10. You will see that now this multicast source must start to receive replies from there as well. Not yet. This is for 230.1.10 itself, right? Onto R4 interface FA0/0 IPIGMP version 2. On to destination also I will say IPIGMP version 2 and then once again so this thing. Yes, it has started to get replies from there as well, right? And one more thing that I would like to show you over here, I will move on multicast destination and from destination as well I will ping the same, I will generate the same string. So you will see that it will also start to receive replies from there as well as from itself. Oh my god, it's 232. I have to make it 230. See, have it proved or not? Multicast system is going there, that is why we are getting replies from there. And also you can move on to this device, it is also getting replies from itself as well as from 4.10. So see, multicast source is source as well as receiver. This router is also source as well as receiver at same time for the same group. And then after you can move on to R1 and you can check its mroute table, show IP mroute, check it out. It will show you bidirectional now. Wait, bidirectional, check it out. For 230.1.1.10 actually, you see, you will be able to see everything. There is no S, G entry for it. Because source of course will be too many. That is why there is only and only star, G entry. And RPF neighbor will be configured towards RP only. That's it. So bidirectional PIM is also finished now. After going through it,
RPF number
would be towards RP, because this is your RP and RPF neighbor is going to be 12.1.2, because to reach R2 this is 12.1.2 from R1. This time RPF neighbor will not be towards the source, because source can be anyone. That is why there will be source will be towards RPF, and you can also go through its theoretical concept, that what is the concept behind it. Just read your book, you'll find each and everything. Then after it, now inter-AS multicasting. Inter-AS multicasting. Are you getting my point? Like if you are having two different ASs and you have to configure multicasting between those two different ASs, then what will you do and how will you do that? Right? The problem is, like, let me stop all these devices now. Like this is R1, this is R2, this is R3, R4, R5, R6. Then they are also connected, right? PIM is running everywhere. PIM is there, and here it is BGPS 100. Here it is BGPS 200. So it will be EBGP neighborship over here, right? Fine. PIM neighborship is there. PIM is everywhere because multicast routing is running over there, right? PIM, PIM, PIM. Now for AS100, you configured R1 as a RP. You will never give your RP's information to another AS. And let's say for AS200, you configured R6 as a RP. Fine, you have configured RPs in both domain. Now there is a source. Behind R1 you are also having one another router. Behind here it was a source. Definitely this router must be having that who is RP, right? So it will register itself onto its own RP, is not it? It will send register stop, it will send register, and then it will send register stop. It means that this source router will register this group onto this RP and this source as well, right? That okay, for this group this source is originating multicast stream. It will register itself onto R1, fine, onto RP, great. Now there is a user behind R6 wants to join that group. For this user, this is RP. Does it have any information about that group and source? Does this R6 have any information about that? Did it receive any register messages from there? So will it be really possible for R6 to join? Hello, will it be possible for this group member to join that group now? Because its own RP doesn't have that group's information in its mroute table. And this is very small example. You can take an example of big organizations. Of course, it is not possible over there, right? So what will you do now? You have to configure a common RP for both ASs. It's not it. You have to define a common RP. That is also not possible because you cannot have common RP for all organizations all around the world. Are you getting my point? So for solving this problem, here we are having a protocol which is known as MSDP, Multicast Source Discovery Protocol. Multicast Source Discovery Protocol. So this protocol will be used for performing inter-AS multicast routing. In case of inter-AS multicast routing, we will always use MSDP, Multicast Source Discovery Protocol. What do we do actually? We will configure MSDP in between these two RPs. We will configure MSDP peering, but remember that they must be reachable to each other with using unicast routing, right? Then configure MSDP peering between them, MSDP neighborship. After configuring MSDP peering, what will happen now? In case if anyone registers itself onto one of the RP, let's say that this router R10 registered itself onto R1. Now R1, this RP will see that am I having any MSDP peer? If it is having any MSDP peer, then it will send some SA message, source active message, SA messages towards that MSDP peer. And in that SA message, it will tell that for this group address, this source is originating multicast stream. For this group address, this source is originating multicast stream, right? So this RP will inform another RPs, like in different domains, right? I mean, this RP will inform to all MSTP peers that this source is originating multicast stream for this group address. So that at same moment this R6 will also create S, G entry in its mroute table. So in near future, if this group member wants, I mean, if this user wants to join that group, then this RP is also having that information, that group's information in its mroute table. So in this way, now they can join this group. So you will not require to have a common RP for all. So basically, if you want to interconnect all RPs together, then you will interconnect them with using MSDP, multicast source discovery protocol. Do one thing, tomorrow come with some preparation, right? Self preparation, read something related to MSTP, and then tomorrow I will implement in very first half, and then I will start your DM VPN. It will not take now so long time to complete this MSTP for me, right? Are you okay with it? So today we covered so many things of multicasting, so it will be better for you to stop this class now and just to revise it if it is possible for you guys, because I don't think so that anyone of you took these classes seriously, especially this multicasting.